Good morning, good afternoon, or good evening, and welcome to MESA's 2018 Smart Story Awards Winners Interview webcast. I'd like to thank you for being here and helping us celebrate the smart people who are doing smart things to move their businesses forward. Next slide, please. We'd also like to thank our media sponsors who make this program possible. All of the organizations that you see listed here help us get the word out about this important program. Personally, I believe that the opportunity for people to hear from one another as far as what they consider to be smart stories and smart successes is one of the critical pieces that we need to drive the whole industry forward in the area of smart manufacturing. Next slide, please. I'd also like to thank our Keystone sponsors. The Keystone sponsors at MESA International underwrite the operations of the entire organization on a global scale, and they make everything that we do possible. We would not be able to exist as a global community if it was not for the domain expertise and the resources and the support that we get from companies like this at the Keystone sponsor level. So thank you, sponsors. Next slide, please. And before we jump in to the webcast here with our presenters, we just wanted to remind everybody that all of the stories that you'll hear presented today, as well as all of the other stories that were submitted, are available for download still at smartstoryawards.com. We're also excited to announce that the 4th annual Smart Story Awards contest will open on March 1st and run through April 12th. So please support this and get your stories ready to submit, and the stories will go live beginning on May 1st. Next slide, please. So just a few housekeeping tips here, and we'll get into the meat of the webinar itself. If you'll notice, on the right-hand side of your screen should be the control panel for today's webcast. There is an orange arrow or a white arrow in an orange rectangle that you can press to open and close that panel and get it out of the way if you don't want to take up space on your screen. There should also be a questions panel there where you can submit a question for our panelists today. So we will take a few minutes for everybody to review their stories, and then we will have a question and answer session at the end of our webcast. So any questions you have, please submit them in that chat box or in that question interface, please. We will be recording this presentation, and the recording along with the slides will be posted to the MESA Resource Library within 1 week. So next slide, please. So with that out of the way, I would like to get into the meat of our webinar for the day. And we will have Khris Kammer, who is the chairman of our Knowledge Committee, the longtime contributor, longtime leader of our Knowledge Committee, will be the moderator. He will run us through the presentations today and through the question and answer session at the end. So Khris, you take it away.
Thank you very much, Mike. Appreciate it. And welcome everybody. We're very proud to present the winners of our Smart Story Awards here for 2018. So without further ado, I'll jump right into it and give you a brief introduction of each of our 3 presenters, the 3 winners of the award. First will be Dr. Raffaello Lepratti, Vice President of MOM Business Development and Marketing at Siemens. And the title of the smart story that was presented by him and his group was Defining Closed-Loop Manufacturing Using Manufacturing Operations Management to Power Smart Manufacturing. So I'm sure you can imagine that was a very popular story, in fact, the most popular. Second, we'll be hearing from Wellington Giolo, who is Senior Director for Pre-Sales Services and Strategic Alliances at 42Q. And his story is entitled Upgrading from a Legacy MES System to a Cloud-Based MES Platform, which is also a very intriguing topic these days. And then third, we'll hear from Martin Kelman, who is Global Innovation Director at ATS. And his story that he'll be presenting is the Collaborative Industrial IoT Solution for Aerospace. So I'm sure all of us will have a keen interest in that as well. So if we can move on to the next slide, please. First thing that we'll do is give you a little bit better introduction of Raffaello Lepratti, again, the Vice President of MOM Business Development and Marketing at Siemens. Specifically focused here on his story. We're going to be talking, or he's going to be talking about how to create a technology infrastructure capable of harnessing the power of massive data and converting that data into greater efficiency and quality. So there were numerous results that came from this implementation of this strategy, and that includes improvements in the areas of speed, quality, efficiency, and agility in the manufacturing workplace, as well as a proactive improvement with closed-loop feedback and intelligence rather than retroactive look-backs. And in the long run, also, this has helped their customer achieve improved product life cycles for future products, so improving the time to market of the goods that they produce. So with that, I'll let Raffaello go ahead and spend a few minutes here. We're going to have each of the presenters spend a little bit of time presenting their story before we start with the Q&A. So we'll ask to move on to the next slide, and I'll turn it over to you, Raffaello.
Thank you, Khris. From my side, good morning, good afternoon, good evening to everyone who's taking part at this webinar. I'd like to thank everyone who was showing interest in the white paper that we were posting through the MESA channels. And I'm walking you through the story in a nutshell about the content and the message that we were providing with this white paper. First of all, I'd like to contextualize what means smart manufacturing, which we at Siemens have been associated with basically two streams of innovation. And one is related to smart products, smart equipment, and smart environments. And the second lever is connected to, or related to connected tools and data and an extended network within a manufacturing enterprise. And exactly the second lever is the point of focus of today's discussion. And if you think about what is the real situation today at a manufacturing enterprise, you might simplify representing the flow of data through what we call the golden triangle, which is basically the financial level, the ERP supply chain side, then the innovation level represented with the engineering part of the manufacturing, but also the product design, so the PLM, and of course the operational level, which is more the production context. And the golden triangle is for us the core of making data flow from a single angle of an organization to another one, and enabling data reaching the right stakeholders at the right time with the right information. And this is for us really driving the digital transformation within a manufacturing company. So today we have the situation that the golden triangle is showing a lot of broken communications. This is driven by different tools, it's driven by different organizational setups, it's driven by different geographical setups, and this is one of the current broader situation we can find looking across different manufacturing industries. So if you look at the next slide, the question is, what if we would really be able to align all those data and the flow and making sure that we have a looping part, a closed loop part of the data that is coming from the ideation of products, so the product design, the planning of the manufacturing, through the realization part, which is in the manufacturing operation itself, and you can extend it, of course, to the aftermarket, also in the what we call the utilization part. So what if we will get our ducks in a row and get this really aligned in a way that we can have consistency of data and reusability of every event that makes sense to be considered to transform into an actionable insight for a stakeholder of the complete product lifecycle. And therefore, we call it closed-loop manufacturing. If you go to the next slide, please. A concept associated with closed-loop quality, and that is for us closing the loop of data. There are a certain point of time start with the planning part. So as soon as you are really designing your product, you start allocating and planning a lot of different activities. This plan go into a do phase, a check phase, and the act phase, and then again in the plan. So for us, it's important to have a closed loop flow of information that are related to execution of manufacturing. So are we really executing in the right way we were planning? Are we really executing with the right performances we are expecting to get out of this? And then the quality piece, are we really realizing the product at the right quality that we were expecting? And are the quality not only related to the product itself, but the processes also at the right stage? So if this is not the case, we need, of course, to have a closed loop, a feedback from the reality to the virtual world of the planning part, so the ideation. And that's where we can transform manufacturing suddenly into a source of improvement also for the planning departments. So this is the way we see how we can leverage collaboration within an organization with manufacturing company by consistent data structure, so without duplicating data, by reusing data in a certain structure, automating responses. There's a lot of rumors around artificial intelligence. We can call it simply intelligent algorithm that understand what an event is triggering as consequences and what impact this would have on different stages along with the product lifecycle. And contextualized feedback, very important, because we always talk about big data. At the end of the day, we need to give smart data back to the stakeholders, and there has to be contextualized properly what's happening when the data was generated, what was the shift, what was the basically the situation, what was the product impacted, what was the tool used. That's what we need to do, and not just forward each and every data. And of course, the continuous optimization loop should bring what is the fifth essence, I would call it, of the expected outcome. So more agility, a quicker time to market, a higher quality and a flexibility of all the processes, again, from the ideation to the realization and to the utilization. This is a general statement, and of course, we need to consider the flavor of the different challenges in the industries. That's why, looking to the next slide, this is about really adopting the different challenges, or adopting closed-loop manufacturing quality to the different challenges of the, I call it, clusters of industry, or different type of processes which drive some industry. If we look at complex manufacturing associated to power generation or aerospace and defense, or heavy equipment where we have a low volume, high variant kind of process. So you really need to, while building an aircraft, you need to identify, if you identify any discrepancies or any divergences you have during the assembly of the aircraft, and be able to feed it back quickly and in the right context to the planning team, in order to have actionable insight and decisions, in order to make the right changes and feed it back to, again, execution part. So it's a constant change management that is happening during manufacturing of one aircraft. Differently, if we talk about repetitive manufacturing, where we have basically the need of, if you look at electronics, consumer electronics, to be the first at the market. So it's most about how can I build an automatic bridge from the PLM to the MES, to the MOM, in order to really to automatically populate the MES and the MOM tools to automatically generate electronic working structures, and also to understand upon a certain defined threshold, so what is happening on the quality, what is happening on, and then feed it back in another kind of mechanism, of course. But the focus will be to be the first at the market. So shorten time to market is clearly more the focus in the repetitive manufacturing. The process chemical industry is more about how can I really make a formulation or a recipe also executable, and this is all about really transforming the formula into an executable formula, and that, so we call it also closed loop manufacturing, although this is of course a continuous process and have a very different challenges what concerning this kind of industry, chemical, food and beverage, primary part, of course, as well as pharmaceutical with a regulated part in that. And then the fourth one is the automotive, where of course we have a unique challenge here to basically be the quickest at the market with the highest quality, and basically also with the flexibility to manage more and more variancy and complexity in the configuration of the models. And just to conclude, in the middle, additive manufacturing is what is basically today is putting the classical process industry or continuous batch process and the discrete industry into a question mark, because this is going to drive a kind of a hybrid process, and where we are actively going to market and helping manufacturers to adopt additive manufacturing processes also in the different areas. Having said that, I'm looking forward to the conversation afterwards and giving back the word to Khris. Thank you.
Well, thank you, Raffaello. Again, that was a very insightful introduction, I would say, to your Smart Story Award. And I encourage anyone who hasn't seen it to download it, and download all three, if not some of the other submissions. But thanks again, Raffaello. Appreciate it. Looking forward to the question and answer session with you. So if we can move on to the next slide, I'll now introduce Wellington Giolo, who is the Senior Director of Pre-Sales Services and Strategic Alliances at 42Q. And Wellington's story is a case study for one of their customers that explains how the company replaced a manually built homegrown MES system, legacy system, with a newer cloud-based MES system. And this was for quite a sizable organization. So Wellington, your story is mainly focused on flexibility and control of the production flow, as well as taking great advantage of machine connectivity for real-time decision making. And I'm looking forward to your presentation here. I'll let you take the floor. And so if you want to take over from here, well, go for it.
Thanks, Khris. Good morning, good evening, good afternoon, everyone. Thanks for joining today. And as Raffaello mentioned, thanks for downloading the stories and voting and providing the feedback on us that you based on those so far. One thing you guys are gonna notice, and Raffaello, open up the floor here. Even though it's different stories, you guys probably gonna notice that we all touch on similar things, and that tells us there's a trend of the market out there. For that specific case, we're dealing with a high complex process where they had key things that they needed to manage and control. That includes serialization, track and trace, real-time visibility, force quality framework, and machine connectivity. And we saw some of that in the previous story as well. The customer needed to have some experimental product runs, as well as change management. And one of the things that we also allow with our story is that once, we'll talk more about that in a few, but once the solution was implemented and fully deployed, for their initial facility, they were able to expand that implementation into a location in India by themselves within weeks. Next page, please. So when you look at the challenge of the company, it was a high volume company, high complex industrial equipment systems that needed to replace, as Khris said, their homegrown MES system for its automated manufacturing line in order to improve and streamline their operations. And there are a few things out there that they want to ensure, the new solution would do in order to meet their needs. One, the system needs to ensure a smooth day-to-day operations during the upgrade process, as well as to enforce complex routing decisions and real-time decision-making capability. Again, they would not stop what they're doing. They had the system. The system had to be up and running while we were implementing the new one, and the data would have to match. And there were challenges on both sides. There were challenges on their side to make sure that it would run both systems in parallel during this transition, and there were challenges on our side to make sure that everything would happen as smooth as possible from the operator point of view. Also need to connect 100 plus machines that include process equipment, printers, test stands, covering over 11 different processes for that specific facility. Traceability of chemical modules produced in one place, and it would feature be integrated into a system module in a different facility. So it's a multi plant scenario where, even though again that specific pilot was in one location, we're moving the final project on our location. We had to have the full traceability of those modules. Need to have a flexible UI to support different manufacturing steps. And a good example, so in certain cases, you have the operator. Well, we have a lot of automation, not a big deal from the operator point of view. In other operations, you have the operator facing, the test station. So the regular UI would basically do its job. In some cases, we had the operator 10, 12 feet away, and he or she must be able to see what was out there and perform the job as needed. That was one of the problems they had previously. And basically providing complete visibility across several plants around the world. And as I mentioned, in this case, piloting one unit, shipping unit, the final chemical products or modules to different units, and then implementation into a different facility in India. So, and we accomplish all that at the end of this pilot, this experience, and we're going to talk more during the questions and answers, if you will. Having said that, so I complete, our introduction here, and I look forward to your questions in a few. Back to you, Khris.
Great. Thank you, Wellington. So we'll move on to the next slide. And last but not least, we will introduce Martin Kelman. Martin is actually the Global Innovation Director for ATS Applied Tech Systems for the story that was submitted around the collaborative industrial IoT solution for aerospace. So really appreciate you being here, Martin. Your case study is around a collaborative industrial IoT solution, so IIoT, the acronym that many of us are familiar with in the aerospace industry, for a manufacturer who wanted to increase their production output, and we're really looking forward to hearing more about it. I read through the story; it was excellent, and it focused on improvement of the network itself, the resilience of the network and reliability of the network, while reducing the total cost of ownership of those assets and of the network itself. And the real goal was to connect IT and OT, which is something that is a central theme of smart manufacturing, and was specifically focused on movement of order data and the usage of RFID tags for tracking of individual units around the facility. So with that, Martin, if you want to take a short time here and present a little bit of an overview of your story, that'd be great. And then after that, we'll move into the Q&A.
Okay, thank you, Khris. Yes, and also thank you to MESA for holding these type of events. I think it's very good that people have the opportunity to promote the work that they've been doing over the years, because I know within our industry we need to celebrate these types of things. So thank you to MESA for holding this. So really this project was has many facets to it, really, because it's not just a technology project. It's about a manufacturing or an assembly improvement project for that particular customer. So what they were really looking to do is introduce innovation into their facilities without disturbing that innovation. They defined this as their best practice manufacturing environment. And they actually worked collaboratively with one of the catapult centres in the UK. And ATS is a Tier 1 member of the catapult centre. And we've been working together on this kind of best practice lines, looking at various things from ergonomic modelling to a discrete event simulation to see how the best layout for that particular line could be implemented. So from a point of view of being able to draw various different suppliers into the project as well and work together to achieve the end goals. And those end goals, as much in aerospace, are really around quality. If you improve the quality of your right first time, then that increases your production output. And by that, because it's aerospace and a lot more business are involved with now, is about the increased traceability of those parts. And with traceability, you want more information. So we also had to think of the pragmatic situation, because like I said, originally this was a project defined within an innovation center, but we have to introduce it into that production environment. So we have to look about how we're going to integrate with their existing systems and their MES systems, which was complicated also by the fact that they were transitioning from a legacy MES system to a new MES system themselves. So we had to take that into account and allow for that separation between the data models involved with communicating between two MES systems, not just one. Then we want to be able to automatically track that data and push that data through the actual part itself. So the part will track that information through the RFID tags that are used through the process. And then we also got the challenge that we'd already implemented the ATS bus at one of their sites, and we needed to be able to extend that to this new facility. So multifaceted from a point of view of introducing standard processes, new technology, and solving the problem in integrating into a legacy production facility. So if you'd like to go to the next slide. So this is the, I can't actually show necessarily the layout of the shop floor, but this was the layout of the information bus, the manufacturing service bus that ATS provides to integrate factories. So as you can see, we've got the legacy Site 1, which also had a legacy MES system. And we'd already integrated that legacy MES system into a production line type of flow. So it was for a composite manufacturing flow line. But we, like I said, we needed to be able to extend that to another site, because the MES system was for the whole of the UK, for all of the manufacturing sites. So as they moved from the legacy system to their I-based East Lumina MES system, we had to manage that transition, but then we also had to introduce a different type of manufacturing process. So before we'd had a process flow line, this time we're into an assembly line. And that assembly line had been re-engineered, as we said, redesigned based on various simulations. So the input to the assembly line was a kitting process, which was had a WIP, work in progress board, so some kind of Kanban system where the kits were being fed into this particular cell. Inside the cell, there's various RFID antennas. So there's actually 3 stations of those RFID scanners. And then we'll track the parts or the kits through the cell to the relevant manual workbenches. Those workbenches were kitted out with smart tools, so Atlas Copco smart tools, hand tools, vernier calipers and things like this, and a whip tracking display. So there were 2 of these workbenches, both laid out in a similar way, looking at the best way of laying it out so the operator can use it as easily and quickly as possible. The materials could be fed and tracked through the process, and we could integrate the information coming from the MES system as well. So some of those challenges were around the level of data coming from the MES system. Had already got the work order information contained within the information we were receiving into the ATS bus. And it had the steps of the process, but we had to match that up to the RFID information. So as the RFID scanner read the information from the part that was stored within the whip, we would correlate that against the appropriate work order information from the MES system. That would then allow us to enable the smart tools based on the information related to that particular step in the work order. So was it a vernier caliper? Was it a smart tool, torque wrench that needed to be enabled? We would enable that torque wrench with the information that we had contained within the B2ML message that we received into the work center cell. And then from then on, all of the communications with the RFID, the smart tool, with the whip tracker, with the hand tools was managed within the smart engine inside the work cell. So the ATS bus is a distributed architecture. So each of the points within the bus can work autonomously based on the information that we receive from the MES system. So as we step through the process, for an example of that is that we'd receive that information, we'd enable the tool, we'd send the tool, the torque wrench, the settings for the particular thing that they had to do. We would capture results of that information, and then we'd feed that back to the MES system. We'd have the same information flowing onto the other bench, so we'd be managing both 2 sets of orders, 2 sets of parts with different information at the same time, all correlated through the one work center stop within the ATS bus. So we were stepping through that process, collecting the information, but what we could also do is validate the information to make sure that the information was within the tool settings and making sure that they could repeat that process if they needed to change those tool settings as they were going through. So that was preventing any non-conformances moving down the process from rather than having to go back to the MES system. We could control that at the edge based on the processes that we were following. So once we'd completed the process of capturing all that information from the cell, then we would correlate all that information back to the correlate all of the process variables that were captured from the vernier calipers and the smart tools, and we'd correlate them against the individual serial number that would have the RFID information. We'd update the whip tracker on the status of that particular part, and then we'd post that message back to the MES system. And remember, that MES system was on another site with an update of that particular information for that particular part. The order itself could contain many serial numbers that had to be manufactured for that part, and we would keep a track on those serial numbers in context to the order that was being generated. So all of that setup was done, and we introduced that a line into the production facility. So originally the line was set up within the Catapult Centre in the UK. Then we transferred that to the facility. We added it into their existing infrastructure, changed over from the legacy MES system to the new MES system. And that kind of completed the integration of those types of things. So if you'd like to go to the next slide. That kind of completes the story of where we were with the white paper that we generated or submitted for the Smart Story this time. But since then, we've also been working with the same customer to extend this once again This time to integrate a robot cell. That robot cell has a couple of robots within it, one to handle the material, one to load different machinery within the cell, one to do quality checking, one to do machining of those parts that within that robot cell. So this is how we're extending the same infrastructure without having a minimal impact on the existing production line, the existing best practice cell, and now introducing a more automatic robot cell. And within that, we'll use the same principles that actually will receive that work order from the MES system, but the HS bus will step through that work order, controlling the robot, what the robot has to do, where it has to deliver that part to, collecting the results from the quality test machine, etc., etc. So it's just extending the original architecture to plug into this framework. So it's a combination of integration of machinery and equipment, integration of devices such as smart tools and hand tools, integration of applications like an MES system, and integration of on-premise applications such as whip trackers, SPC systems, and OEE systems. And the beauty of how we've designed this is that everything, all the messages are available in a producer-consumer approach. So any point of the network, of the distributed network, can publish a message. Any point in that network can consume that message. So not only have you got vertical integration of the information, you've also got horizontal information exchange. So potentially, and as we do on the flow line, you can share data between one work cell and another without necessarily having to go back to the MES system to share that information. So as with many of these stories, these are stories that have been developed, integrated and deployed at customer sites. And as such, there's lots of new and exciting things that we're also involved with that we'd like to share with MESA in the future. So it's been my pleasure to share that with you today, and look forward to the questions. So thank you, Khris.
Great, Martin. Thank you very much. Okay, just wanted to remind the attendees that if you have any questions for the panelists, you can type your questions into the question section of the GoToWebinar. So you'll see that as one of the window panes, and if you might need to expand it, but you should be able to type in any of those questions that you have, and we'll try to get to them. I do have some questions already ready, lined up here for the presenters, so we'll go ahead and get into those. So, it strikes me that every one of these smart stories that have been presented are actual customer applications, and that's really what gives them a lot of value. And surely, the customers or the end users of these solutions saw the value, or else they wouldn't have invested in them. And so what I'd like to do, and we'll do a quick around the room here, I'll start with Raffaello. I'd like to understand a little bit better, and I think the group would like to understand a little bit better here, Raffaello, of what were the elements of the return on investment or cost justification that really helped your end user make the decision to go ahead and drive for this. So this is an area where MESA is doing a lot of work in the area of ROI and cost justification. So would love to hear from you on how you think that relates back to your story, and what sorts of elements, again, are important to the ROI for your story. Raffaello?
Thank you, Khris. Yes, I mean, I tend to say so. Generally, if the approach, the story I was telling is about a broader scope of I think a broader scope of impact, if you would like to call it, because we are close to manufacturing, close to quality. We are trying basically to change a mechanism of how data should go from a place to another. Again, as a company, we really are targeting at enabling the digital transformation at company. So if we are talking about KPIs, first of all, in ROIs, we are talking on a level of granularity which is much higher than, for example, when we help replace a legacy software, or we help connect different softwares where we have a clear TCO on one side and the cost of investments, and then we can make really the ROI calculation, or help manufacturer get the right ROI calculation. So in the sense of the broader scope and the higher impact that closed loop manufacturing and closed loop quality intend to generate, we look at ROIs and KPIs that are basically related to some elements like the go-to-market, the time to market, for example. This is one of the cases that we have published some years ago, one of the most prominent, at least from our end, which was a car manufacturer that was intending to implement an industrial strategy, really first time going from a premium class car segment to a lower segment, and start competing with much more companies, other companies. So they were saying, I need a clear strategy to be realized, and I need for them some of the elements. One of them was I need to manage more complex automated processes, because I'm going to produce from 6,000 to 30,000 cars a year, which means I have to increase the level of automation in my facilities, and at the same time I need to be faster when because I'm going to also to introduce more models and platforms. So I need to be faster in getting to market with what I designing, so the new model. So this was the Maserati case, where we brought at the end of the day, the target was to come to 16-month time to market. I'm talking about 2011. So this was the target, the ROI, because out of that there was a number of elements within in this case FCA was looking at in order to make their calculation, which was not related on, again, some specific TCO or whatever elements. There was related more on transforming or realizing a strategy and industrial strategy they have. Mm-hmm. So this is one example.
Yeah, without reduction of quality, as you mentioned.
Yeah, without reduction of quality. But here's quality, for example. Another example we have in MedDev, where the closed loop manufacturing helps really making a lot of checks and looking at the product and process quality improvements, getting data from the execution back to the planning, so the FMEA, product FMEA, or inspection plan, control plan. Are we really looking at the right angles, what we need, or are we discovering non-conformances where we were not thinking to have that? So it's more about adjusting, fine-tuning this online, I would say, while the process is going. And this is for MedDev very important, in particular for certain class of products. Very important to avoid recalls afterwards when the products are in the market, because of the bigger issues they can. So with this ping pong of elements, you can really make sure recalls are not coming, and therefore there's the biggest KPI. But that's something that is again betting a bet towards a future. You believe you are making a digital transformation as an expired executive of the company. So yes, because I'm sure with this implementation, I'm going to reduce recalls, which are costing a fortune. And allow me a last example, the aerospace defense, where you need there to have the first time yield as one of the most important parts, and where the closed manufacturer is really looking at during producing an aircraft. I cannot fail, otherwise nobody will buy my new aircraft. Airbus, Boeing, no matter, or in China, really first time yield, and this is having a lot of change requests that you need to manage. So I don't know if this is a kind of abstract KPI that is more related to making a strategy happen.
That's great. You gave us a few examples there, and I think very unique to yours versus the other stories here is the time to market element. So appreciate that, and good feedback on how closing the loop actually helps enable that. So if I could, I'd like to ask the same question to our next panelist here, which is Wellington. And Wellington, your story is also very compelling. What elements do you think contributed most to cost justification and return on investment for your end users?
That's an excellent question. I think in our case, it was primarily the fact that we're a SaaS solution. Helped us a lot. So the customer had already made an investment, buying pieces or developing their homegrown application. So they didn't want to go and reinvest this in, a lot of money and having, hardware on site and all that. With 42Q or with our implementation, being a SaaS solution, they didn't have to deal with CapEx. It was purely they have to only deal with OpEx. No local hardware required. It's all cloud-based. And the time from the signature of the statement of work to the time of delivery is a rapid implementation, 6 to 8 weeks. So they could see the ROI right away. And our model, the model of the store, we propose, let's start small. Let's fix the main pain points you have, and let's expand based on your availability, the capability you need, and what adds more value to the company. So it was very easy for them. Let's start with track and trace first, for instance, or the force quality framework. Let's validate this and expand. What they, as you I mentioned before, the main thing for for that specific case was with visibility, force quality framework, and efficiency. And once you have a solution in place within 6 to 8 weeks, you don't have to invest. And what I mean 6 to 8 weeks is from the time you start to the time you finish, you're up and running 6 to 8 weeks, and you don't have to invest in any local hardware. You are, purely connect to the cloud, and you can immediately realize the return. You can measure, okay, how much more visibility I have right after, my first batch. How my routing enforcement is working? Do I have better visibility about what's going on? Am I assuring that I'm not shipping products out the door that hasn't been processed on the specific units? Mm-hmm. With all that, we dropped the total cost of ownership anywhere between 20 to 30% in that specific case, depending how you look. And the main factor behind this, again, is an OPEX model. It's not a CapEx model. And the technology also behind the thing allows the company to eliminate even some of their own hardware. For instance, if you're running with that cloud solution, because it's pure cloud-based, you don't have to rely on anything else but a browser. So companies today trying to remove or eliminate or even reduce some other license like Microsoft and others, they can get away with that and purely, get connected to the browser. That also help with the total cost of ownership.
Sure. Mm-hmm. Yeah. Well, that's excellent. Obviously, the movement towards the utilization of cloud-based infrastructures and, basically the ability to move a lot of these expenses into, or I should say out of CapEx and into operational expense has been a real boon for a lot of people. So it makes sense that, if this solution that you've deployed was, purely cloud-based, how that can offer a lot of value to your end users. So thanks for that. And now I'd like to ask the same question of Martin from ATS, because I know their solution also provided a lot of value to their end users. And Martin, I can probably take some guesses, but do you want to chime in on maybe what are some of the unique elements of value that were offered by the solution that you guys provided?
Okay, thanks for that. So yeah, it's one of the things, as we kind of alluded to as well, is that this was how do you insert innovation? How do you insert new technology, new processes into a business? And sometimes a lot of money's invested and wasted on multiple innovations, on multiple sites, or multiple customers have lots of projects that they're unaware of. So the impact of shadow projects is a big problem. So this is one of the reasons why they called it their expert line, because they wanted to create a standard process for these types of things, and then they can package that, and then they can roll that package out throughout anywhere that they do these types of operations. And by doing this, you've got instantly you're reducing those overheads of those other projects that are trying to achieve the same thing in other sites, in other areas. The other aspect to it is that we worked in collaboration within the Catapult Center. So this allowed them to reduce the cost and risk around the original deployment. They could de-risk it outside of the affecting anything in their production, de-risk the technologies, ensure that everything worked and was designed in the most effective way. And then once they proved out that and raised the technology readiness level to insert into the facility, they could do that with bare minimum risk. The other aspect is because the approach we've taken, we were training up their own staff to do the deployment. So as a part of the initial deployments we did, we also trained them up on the ATS bus and how to implement the ATS bus. And then we took a more of a backward step and allow them to implement some of the rollout with our support, as in remote support rather than hands-on support. So the cost of the original one is a little bit more because you put more effort into that. No more than it would be if you're doing this by yourself, because all the other reasons I've already given. But the rollout now is a cookie cutter approach, really. So especially with the things like the Atlas Copco interfacing, the vernier caliper interfacing, the layout and design of the line, all of that now is their kind of, the whole package of it is their property to now cut and implement in whichever facilities they want globally.
Sure.
So I think all of those things are just about reducing the risk, reducing return on investment, and achieving your, the quality and throughput and the traceability, and also, supporting the investment they've made with their MES systems as well.
Sure. Well, I appreciate that, Martin. And actually, I'm gonna ask you a follow-up question, and I'll move back up to Wellington and Raffaello for some other questions as well. But you had mentioned in your presentation B2MML, which is quite prevalent. So this is the business to manufacturing markup language, which is a piece of MESA IP. Can you comment on the value of standards in general, and in particular that standard, and how it contributed to your ability to especially involve multiple systems here to be able to talk to each other?
Yeah, and that's kind of key to give that level of abstraction. As we said, the legacy MES system, going from one to another, or even having both running at the same time, is possible within that infrastructure. But to give a level of abstraction around a standard that we can agree on, and I think B2ML is, there aren't many other standards in that approach, especially compared with the amount of standards and protocols there are to communicate on the shop floor. That's for sure.
Sure. Yeah.
So so that really has given us and our customers that kind of confidence that they are abstracting away. They're not being baked into whatever solution is, because they've already got that semantic model all based around the B2ML schemas that allows them to know that if any part of that infrastructure is swapped out, it's just a case of changing that one element to it, and it doesn't affect anything else within their facility.
Sure. Yep. Well said. Appreciate that. So, just kind of going back up through the rest of the group here, Wellington, any comments on implementation of standards and whether or not that actually is something that you encountered and have been able to employ in your implementations?
Oh, absolutely. Again, we have 42Q being used in some highly compliant requirements like automotive, aerospace, medical, and following the regulatory compliances and the standards out there does help and bring us some peace of mind to our customers.
Mm-hmm. Mm-hmm. Yep. Good. Raffaello, clearly, in order to achieve the closed loop vision that you painted earlier for us, I'm guessing that you also had to employ some standards and use them to try to connect some systems that otherwise weren't connected. Can you comment on that briefly, please?
Yes, I can. We definitely need to take into account, on the one side, the willingness of manufacturing to make a big change in the organization, what I was talking before. On the other side, also to help him ensure past investment to be safe for the future as well. So we do have, if we are talking about connecting system as, for example, third-party system or legacy system, this is where we of course we have an open connection towards the shop floor automation or towards also the ERP level, in order to make sure that we are not only focused on our own blueprints, let me say, or our own tools. So there is a model that we normally share to make sure that a company can, despite the big topic of CLM, CRQ, can start focused on a single piece and scale up towards the implementation of the complete CLM, CLQ. And here I saw, if you don't mind, also the question of Wanda Vincent that was posted to reference to what should be actually the first step in order to really take visibility or gain visibility for a company that's having ERP to manage planning of manufacturing and not having visibility in what is happening real time in the manufacturing operation area. And this is the key. If you want to start with closed manufacturing and having the closed manufacturing and closed quality providing you the full blown value that I suppose there is, of course, a need to have a visibility what's going on in, I call it real time in different levels, what's going on with your equipment, with your resources, with the material, with the consumptions, that at the end of the day is not just related on inventory, how much is forecasted to be used, how much is really being used after 24 hours after a shift, but it's really looking at what I'm consuming right now and what I'm forecasting consuming within the next hours, what is not working probably. So an MES, as part of MOM, is giving this transparency, of course, with the ability to connect to different equipment. And yes, that's, I hope, an answer to your question, Wanda.
Absolutely, and you actually, we have only a few minutes left here, but I did want to expand on that a little bit and also include the rest of the group here. You mentioned visibility and real-time visibility and how that helps with decision making. And I'm going to put everybody on the spot here, so I apologize. We'll let Raffaello go last since he was just talking, but I'm going to start with you, Martin, and then we'll go with Wellington next. So I'm going to ask you literally in about 30 seconds, give me an idea, or give the audience here an idea of how real-time visibility affects decision-making in the smart story context that you've presented. Martin, can I ask you to go first?
Yeah, so I think real-time decision-making is very, very key. But when I say by that is what we're looking to do is running those out to us. The area to have those decision-making is at the edge. Okay, you can run things in the cloud and things like that, which is very important development, I think, for manufacturing. But actually, once the cloud has maybe come up with those algorithms to me need to be ran at the edge to create that kind of cyber physical world. And the more knowledge and experience we get with running those decision makings, the less visible I think some of that decision making will become. So that's slightly contradictory, because at the moment the visibility is there for the human to make the decision. We need to get to a position that we are using humans to create the algorithms, but the decision making is being made at the edge.
Good. No, that's very interesting. It's not all cloud. Edge is a very important element too. We're running very short on time. Thank you, Martin. Wellington, can I ask you to give me 30 seconds on that same topic? What do you think about real-time decision making and how real-time visibility comes into that?
Well, not much to add. I think Martin explained the scenario very well. But one thing I would like to mention is that, when you look today, most of the systems will provide you with real-time visibility. I think the key, to Martin's point, one is the algorithm behind it, but most importantly is what kind of information you're providing in real time, because one thing we learned from our experience, you cannot overload the customer with too much data, mainly when you're transitioning our story, for instance, when you're going from a homegrown application where they didn't have much, and if you overload them with information, they're probably going to make poor decisions, and we found that out pretty quickly. You got to work with the guys, understand what the main needs are, and how we're going to make this available, and how the system can support also then to make decisions, to Mark's point. So there will be human beings at the end of the day looking at the real-time visibility, the real-time information to make the appropriate decisions for the business. And that comes with the technology, obviously. And Martin mentioned, and we all mentioned, cloud will facilitate all that with the algorithms and the knowledge base behind of all that should guide you through this journey.
Excellent, excellent. So I'll give you the opportunity to give us a couple of closing comments on that same topic, Raffaello. Any comments additionally on real-time visibility and decision making?
I will be very brief. I would say real-time visibility is key in order to understand where a real-time decision is required or not. A real-time decision is today depending on where you are and what is the challenge. If you are on the automotive assembly line where you're ready to take a decision or going ahead or not ahead with jeopardizing and stopping the line, this is a real-time decision you need to take on operator. On a supervisor level, you might have another kind of real-time. What do you think about? Yes, I should act probably, but not right now. Anyway, the real-time visibility of what's going on is the most important thing. I guess in the next years with the artificial intelligence, we will get more data pre-processed and displayed in a way that we might be able to get the right suggestion to be more concise in taking real-time decision as well. But this is today depending really on the context we're talking.
Great. I appreciate those comments. If we could advance the slide then, what I'll do is we're running a little bit late here, but appreciate everybody hanging on, and appreciate all of our presenters and the submissions of everybody that we haven't necessarily represented here on this call. I'd also encourage all the attendees and listeners to go ahead and take a look at the Smart Story Awards online. You can download them at smartstoryawards.com. And don't forget that we are starting up our 2019 Smart Story Awards contest. So we'll be opening up March 1st through April 12th for submissions there. So get ready to get your stories out there. We'd love to have you on one of these webcasts coming up in the future. So with that, I believe we're ready to go. And I appreciate everybody joining. Thank you very much, and looking forward to having you on another MESA webcast in the future, and even better yet, to participate in this sort of activity yourself. Thanks again, and have a great afternoon or evening or morning, wherever you are.